Hello everyone, for this tutorial video I'd like to explain differentials as well as the equation for them and why they're useful/applicable. If we remember, one of the definitions of the derivative was dy over dx, so it follows that dy should equal the derivative times d of x, and dy means differential of y. This means if we have change in x as a change in x, and change in y as the function of x plus change in x minus the function of x, we can see that for changes in x sufficiently small, changes in y are approximately equal to the differential of y. This means that we can compute tolerance for errors when manufacturing objects using differentials. For example, if we know that we measure the radius of a sphere to be 45 inches, and we want a possible error margin or error tolerance of no more than 0.01 inches, it follows the differential of v equals 4 pi r squared times the differential of r, because we are taking the change of v relative to the change in r. And because the change in r is sufficiently small, we can state that the change in volume is approximately equal to the formula we derived, and we compute this, which is 254.47 cubic inches. We see what the error margin for the change in volume is by dividing it by the actual volume and then multiplying by 100 to get a percentage. We see the error margin is 0.0067%, which is good for most applications, as generally we only want to be very precise when manufacturing industrial technologies or something similar. Now that we have seen how we can use the differential to compute the error margin, we can explain the final type of application of derivatives, which is used in accounting/business applications, as in finding the marginal cost of something. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.